Welcome back to our flipped classroom videos. We're going to move on today to graphing quadratics in factored form. Yesterday you graphed quadratics in vertex form, and we looked at all the different parts there are to a quadratic equation. We talked about the vertex, we talked about the growth pattern of a quadratic, and now we're going to move into a different form. Vertex form is very nice, it's easy to use, but it's not always going to be applicable. And so we're going to move into today factored form, which factored form is really nice for connecting some of the stuff we've done previously to graphing. So when you look at our equation here, y equals x plus 3 times x plus 5, we start with a simple question. What information do we have about this graph? Just from looking at the equation, we should know some things about the graph. Hopefully, all of you said this. It's a parabola shape, because we know x plus 3 times x plus 5 is simply the factored form of a parabola. I can multiply that out to x squared plus 8x plus 15. And as we talked about yesterday, any graph of degree 2 is going to be a parabola shape. But then that brings us to that next question of, where's the vertex? That vertex value we talked about yesterday is kind of our core value, what we need to know in order to graph a quadratic. Well, to make that step to a vertex, we're going to make a really big connection right now. We're going to connect what we're doing with graphing to what we did with solving our quadratic equations. Oftentimes, people kind of lose that connection. We do all these shortcuts for graphing. We lose the connection between graphing an equation and solving an equation. So if I think of it in this form, our standard form we worked with for solving quadratics when we factored, we went ahead and did the zero product property, and we've done enough of these that we're going to skip the work and go straight to our solutions. We know x equals negative 3 and x equals negative 5 is the solution to that equation equal to 0. But if you look back at our original equation, y equals x plus 3 times x plus 5, and if you look back at our new equation down here with the 0, the only thing that's changed is I replaced y with 0. So we need to be making that connection that replacing y with 0 means something on the graph. What that means is I've found points that I can place on my graph knowing that the y value is 0. So therefore that means x equals negative 3 when y equals 0. That means this equation has points that I can put on my graph. I can put the point negative 3, 0 and negative 5, 0 on my graph because they're solutions to the equation when y is 0, x is negative 3. So we've made that connection now between when we solve something, you're also finding points that would be on its graph. So now, we still need that vertex. And when we think about what we know 2 points that are on our graph right now, and we know the shape of the quadratic graph is going to be a parabola. And we know all parabolas are symmetric. And remember what symmetric means. Symmetric means exactly the same on both sides of the equation. So if we know these 2 points, our negative 5 and our negative 3, our zeros, are both on the graph, that actually tells us something about the vertex of our graph, because anything that is symmetric must have an axis of symmetry. That axis of symmetry is always going to be located at the middle of the graph, because there's got to be a line where the graph changes, becomes a mirror image of itself, where it goes to the other side. And so therefore, in order to be exactly symmetric, it has to be in the middle of our 2 points. So therefore, the middle of negative 3 and negative 5 is obviously negative 4. So we know the axis of symmetry occurs when x is negative 4. So now, knowing what we know about equations, if I know the x value of a point, I can find the y value by plugging that x value in, just like I did with the y's before up here. When we made y be 0, we found our x's, we found points that are on a graph. Well, by finding x equals -4 as the axis of symmetry, we know our vertex must be on that line. So if I want to find the y value on that line, I plug -4 in for x, and I do -4 plus 3 times -4 plus 5, and that gives me y is -1. So that means my vertex is located at the point -4, -1. So now I know a vertex and a point on each side of the vertex for our parabola. So I can sketch in a general parabola shape. And now yesterday we used the growth pattern, and we could continue to do that to graph our next points. But for today, I just want us making that connection between a graph and an equation. And so we're going to use those zeros, our factors, in order to do that. So here's the steps to graphing in factored form, and we're going to run through these real quick. So if you need to, pause the video to get these written down. How you graph in factored form: first of all, you factor the equation if it's not given to you there. You find your zeros. In other words, you replace y with 0 and solve the equation. Those zeros will also be called x-intercepts, roots, and solutions throughout this course. We'll use those terms interchangeably: zeros, roots, solutions, and x-intercepts. Then we put those points on our graph. We graph our zeros. Then we think about the graph being symmetric, and we find the axis of symmetry, the middle value between our zeros, and that's going to represent the x value of our vertex. In order to come up with our vertex, we must plug our x value into our equation and find y, and that'll give us our vertex. Once we've graphed our vertex, we can then draw our parabola. Let's look at an example of this where you're going to have to do all these steps we talked about on the previous page, and you're going to get a little bit of an ugly answer, but that's okay to get ugly answers. So we start with y equals x squared minus x minus 2. And because we're doing graphing in factored form today, obviously you're going to need to factor that. Y equals x minus 2 times x plus 1. At this point, we're under the assumption you can all factor. In order to find my zeros, I simply replace y with 0, and most of you are going to be able to do this very quickly in your head. All we're trying to do is make each parenthesis equal to 0. In the first parenthesis, if x were 2, you would get 2 minus 2 is 0. In the second parenthesis, if x were -1, -1 plus 1 is 0. So now we have some information to put on our graph. We have our zeros, or our x-intercepts, at 2 and -1. In order to be able to graph this, we said we need to find a vertex. And we said that vertex is always going to fall on the axis of symmetry, which is halfway between -1 and 2. The issue we run into here is halfway between -1 and 2 isn't on an exact number. If we need to find the halfway between two numbers, we can always add them together and divide by 2. 2 plus -1 is 1. 1 divided by 2 is 1/2, or 0.5. So I'm going to sketch in my axis of symmetry here at x equals 0.5. We know our parabola is going to be centered at that axis of symmetry, or that's going to be the x value of my vertex. So in order to find my vertex, I plug 0.5 into my original equation or my factored form. I could plug into either one of these two places. I would get the same answer. In this case, I plugged into my factored form, 0.5 minus 2 times 0.5 plus 1, and I get -2.25. So my vertex is going to fall on my axis of symmetry at -2.25. And again, a graph is always a sketch, so we just estimate about where -2.25 would be, and we draw in our parabola. So in order to do your graphs today, you're going to have to find your zeros of your function, understand the connection between the equation and the graph your zeros, find your axis of symmetry, plug that in to get your vertex, and graph. Good luck.